Good day, students. Welcome to mathgoodserve.com, where we don't just solve, we teach. In this clip, we're going to be going over problems 16 to 20 of the Algebra 2 Common Core New York Regents exam for June 2017. All right, let's take a look at question number 16. It reads, for x not equal to 0, which expressions are equivalent to 1 divided by the 6th root of x? Alright, so what we're going to do first is convert this verbal expression into symbolic form, and then we will go ahead and see which of these are equivalent to it. Okay, so what is 1 divided by the 6th root of x? How does that look like in symbolic form? Alright, let's go ahead and carry out the translation. Let's write down the verbal form first. 1 divided by the 6th root of x. This is the verbal form. In symbolic format can be written as 1 over the 6th root of x. Okay, so the question is, which of these are equivalent to this expression right here? All right, let's start with the first one. For I, we have the 6th root of x divided by the 3rd root of x. Okay, now we can rewrite this as x to the 1/6 power divided by x to the 1/3. Now since we're dividing, we can subtract exponents. Okay, now since the power in the denominator is bigger, I can express this as 1 divided by x to the 1/3, and I'll subtract the exponent in the numerator, 1 over 6. Okay, now what is 1/3 minus 1 over 6? We have to find the LCD. So the LCD of 3 and 6 is 6. So I'll simply multiply this by 2 in the numerator and denominator so that we can have identical denominators. If I do that, I'll have x raised to the 2/6 minus 1/6. When we subtract, we'll end up with 1 over x raised to the 1/6 power. Okay? And then this can be expressed as 1 over the 6th root of x. And that's exactly what we have here. So that tells us that option I is correct. Okay? Now let's shift gears and take a look at the second option. Option 2, we have x to the 1/6 power divided by x to the 1/3 power. Okay? Now if you take a look at what we have here and you examine the work that we did for part I, what you notice is this is exactly the same as the second step in part I. X to the 1/6 over x to the 1/3 when we express these radicals as fractional exponents. So what does that tell us? It tells us that upon simplification, this will be exactly 1 over the 6th root of x, which means option 2 is correct also. Now let's take a look at the third one, option 3. Option 3, we have x raised to the negative 1/6 power. Okay, so how can we express this using radical format? First of all, we're going to use the reciprocal property of exponents. Since we have a negative exponent, we can reciprocate the entire term and make the power positive. So we have x to the 1/6. Now we can now express this fractional exponent as a radical, which would be the 6th root of x, and is exactly the same as what we have here. So this is equivalent also. Conclusion is that all three answers are correct. Alright, so answer for number 16 is option number 4. Alright, let's take a look at question 17. It reads, a parabola has its focus at 1, 2, and its directrix is y equals -2. The equation of this parabola could be, So we're going to use the graphical representation of the parabola described here to generate the relevant components that will input into the formula for a parabola to determine our correct answer. Okay, so let's go ahead and sketch the graph of the scenario that we're dealing with here. 1, 2 tells us that the focus is going to be in quadrant 1 since these two coordinate values are positive. So we'll make quadrant 1 sufficiently large so we can put the focus in there. Alright, so there goes our axis, our x and y axis. Now we're told that the focus is on 1, 2, so let's just call this 1, and then 1, 2, and we also have to go down 1, 2 to hit the directrix. So the focus, let's put that in green, is going to be right here. Okay, so that's our focus. Now, we want to graph the directrix. The directrix is the line y equals -2. So we have this horizontal line down here. That's our directrix. So with this configuration, can you determine the opening of the parabola? The answer should be yes. The parabola normally curves in the direction of the focus, okay, and it's also midpoint between the directrix and the focus. Okay, so between these -2 and 2 right here is exactly where the vertex is going to be. Okay, that is always the case for all parabolas. All right, so we have the vertex there, and the coordinates are 1, 0. Okay, so let's sketch our parabola. It's not going to be perfect, so something like this, opening up. All right, now we want to write down the equation of the parabola. So in order to do that, let's write down the formula first. So the formula for the equation of a parabola is y equals, because it's configured in the y direction, so y comes first, 1 over 4p times x minus h squared plus k. All right, hk is your vertex. And this p-value right here, what on earth is that? The p-value is the distance from, or the distance of the vertex from two possible locations, from the directrix, from the focus, or the directrix. For the directrix, we are looking at perpendicular distance, okay? Not just any distance, the perpendicular distance. So the question is, how far is this directrix from this vertex? What is this distance right here? That is our p-value, and as you can see, it's 2 units. So this graph helps us see that p is equal to 2, and that's our vertex right there. Okay? All right, so now that we have our vertex, so vertex is 1, 0. That helps us to see that h is the x-coordinate, has a value of 1, and k, the y-coordinate of the vertex, is 0. Our p-value is 2. So we have all the ingredients to input into this formula here to determine what the equation of the parabola is going to be. Alright, so let's go ahead and do it. So let's rewrite the formula so we don't make any mistakes. It's y equals 1 over 4p times x minus h squared plus k. Alright, so we have y equals 1 over 4, p is 2, times x minus h is positive 1 squared plus k, which is 0. If we simplify this, that's going to give us y equals 1 over 8 times x minus 1 quantity square plus 0. Okay, so this right here is our final answer. Answer to number 17 is option number 4. Okay. All right, let's take a look at question number 18. So for question 18, it reads, the function p of t equals 110 e to the 0.03922t models the population of a city in millions t years after 2010. As of today, consider the following two statements. First one, the current population is 110 million, and the second, the population increases continuously by approximately 3.9% per year. This model supports. So is it the first statement that's correct, the second, both, or neither of them? Let's take a look at the first statement, which is that the current population is 110 million. Okay, so if you take a look at this model right here, can you determine what the initial population is? The initial population is when t is equal to 0. Okay, so let's consider the initial population at 2010, where t is equal to 0. Let's see what happens there, okay? So for that, we plug in 0 into the function. So we have p sub 0. Your starting population is e raised to the 0.03922 times 0. If you simplify this, you have 110 e to the 0th power, which is 110 times 1, which is 110 million. Okay, so 110 million is not the current population. 110 million is the population in 2010, 6 years ago. Okay, so 110 million is not the current population. Okay, but that of the start. But that of the start. Okay, and that was in 2010. So is statement 1 correct? Statement 1 is inaccurate. Alrighty, we can eliminate option 1 and option 3. Alright, so is 2 wrong, or are both of them wrong? Well, if 2 is wrong, then neither is 2 correct, or is neither of them correct? Alright, so for that one, the population increases continuously by approximately 3.9% per year. For this one, we're going to take a look at the formula for exponential growth functions that have a continuous growth rate. Okay, we'll extract relevant components and see if the statement is correct. So formula for exponential growth functions. We're looking at the ones that are continuous, okay? Alright, so we have, it's basically the population at any time t is equal to the initial amount, let's call it a sub 0, times e raised to the rt, where our focus is on the rate, so that's what we'll just narrow our focus to, okay? Where r is the growth rate in decimal form. Okay, so you gotta be careful with that. What you see in the formula in the equation is the growth rate in decimal form. Okay, and then r is basically the coefficient of t. Okay, so let's look at the formula that we have. So from the original formula, from p of t equals 110 e to the 0.03922 922t, we can see that r is equal to 0.03922, and that's in decimal form. So what is r in percentage format? We care about the percentage format because that's the format that's presented here for the growth rate. So in percentage, we just have to multiply by 10. Okay? So r is equal to 0.03922 times 100 in percent form. What happens when you multiply by 100? That simply shifts the decimal point 2 places to the right. Okay, it's as though you're taking the 2 zeros here, the 2 decimal points here, and you're moving it over here. So you go 2 places to the right, 1, 2. So the growth rate in percentage format is 3.922%. Okay, growth rate. So is this statement 2 correct? It says the population increases continuously by approximately 3.9%. That is absolutely right. If we round up to the 10th place, so statement 2 is correct. Answer is option number 2. All right, let's take a look at question 19. It reads, to solve the equation 2x over x minus 2 minus 11 over x equals 8 over x squared minus 2x, when multiplied both sides of the by the least common denominator, which statement is true? Okay, so we're having statements concerning the solutions, some being extraneous, or the scenario where none of the solutions are extraneous. So since this problem is presenting options concerning the solution, what does that tell us? It tells us that we have to solve the equation completely and test the solutions that we get to see if they're actually viable solutions or if they're extraneous solutions. Okay, so before we get started with the problem solving process, let's go ahead and refresh our memory on what it means for a solution to be extraneous. Extraneous solutions do what? Extraneous solutions do not satisfy the original equation. Okay? So what does that tell you? Whenever you're solving rational equations, you always want to check your answers and eliminate extraneous solutions. Okay? Alright, so let's go ahead and solve this equation, and then we will test our answers to see which ones are actual solutions and which are extraneous. 2x over x minus 2 minus 11 over x equals 8 over x squared minus 2x. Alright, so first things first, we want to eliminate the denominator. Okay, to eliminate the denominator, we're going to multiply by the LCD. That's what rendered. So to find the LCD of the denominators, we want to factor completely. That really facilitates the process. So we have 2x over x minus 2 is prime, cannot be factored further. Minus 11 over x, that's prime also. 8 over x squared minus 2x, you can factor out an x, so you have x minus 2. Alright, so it's nicely factored. So the question is, what is the LCD of the denominator factors, which are x and x minus 2? The LCD is simply the product, since they're coprime, x times x minus 2. Now, what does this help us accomplish? If we multiply both sides of this equation by the LCD, these denominators go into the LCD evenly. So that means that all the denominators will become 1. Alright? So that's much easier than dealing with this situation here, because it will no longer be a rational equation. It will become a polynomial equation, in this case a quadratic. So let's multiply by the LCD to get rid of the denominator term. So we have x times x minus 2. Both sides of the equation must be multiplied by exactly the same thing, or else you are changing the problem. Okay, so times x minus 2. Okay, now if you take a look at the first one, the x minus 2's divide out nicely. The second one, the x's divide out. And in the third one, the x minus 2's and the x's divide out. So what you're left with is just 1's in the denominator. When you multiply a numerator, you will have 2x times x, which is 2x squared, minus 11 times x minus 2. Now you want to be careful here. There's a minus here. Don't forget to distribute that minus to this minus here. So it becomes 11x plus 2. That's a common mistake most students make. They forget to distribute the minus in front. Okay, equals, and then here is just 8. So as indicated earlier, we now have a quadratic equation, which is much easier to handle compared to a rational equation. Okay, 11 times 2 is 22, not 2. All right, so okay, now let's go ahead and put it in standard form. To accomplish that, we will subtract 8 from both sides. While we're doing that, we want to make it equal to 0. Okay, so we have 2x squared minus 11x plus 14. Now let's go ahead and solve this quadratic equation. It's very likely that we can factor it because our options provided were all rational, so we shouldn't have a problem factoring this. So we're going to put AC on the top and B on the bottom. AC is 28, B is negative 11. So we'll play the X game, okay? The question is, what two numbers multiply to give you 28 and add to give you negative 11? So you exhaust all the numbers that multiply to give you 28, okay? So if you do it correctly, you end up with negative 7 and negative 4. These two numbers multiply to give you that, and they add to give you negative 11. So we're going to insert them into our polynomial function, equation. So we have 2x squared, and then we're going to insert our two numbers that we came up with, minus 7x minus 4x. This will enable us to factor by grouping, plus 14. Alright, so we're going to partition it down the center and factor by grouping, okay? From the first two, we can take out x, factor out x, and we have 2x minus 7. For the next two, we can factor out negative 2. That's the GCF for these two terms, negative 2. And we have 2x, factor out minus from a plus, the sign changes to minus. Now you examine your two quantities in the parentheses. If you factored correctly, they should be the same. They are here, so we're looking good. So what we're going to do is pull out those factors in the parentheses, 2x minus 7. And then the numbers on the outside, we just group them together because that's what's left upon extraction of the GCF binomial term. And then we have x minus 2 equals 0. To finish this off, we'll use the zero product property, set both factors to 0, and solve. So for this one, you just add 7, 2x equals 7, and divide by 2. So the answer for the first one is 7 over 2. And then this one, just add 2 to both sides and you are in business. Now, the question is, are these the solutions to our rational expression, to the original rational expression? The answer is no. These are potential solutions. Okay? How do we know if they are actual solutions or not? What we're going to do is test to see if they are extraneous or not. Okay, so this is where the test part comes in, or you can call it check, whichever way you want to express it. All right, so let's go ahead and test both of them out. We're going to start by testing out the first one. We're going to test x equals 2. How do you do that? You take your equation, plug in 2, and see if you end up with a true or a false statement. Okay, so we have 2 times 2 over 2 minus 2 minus 11 over 2 equals 8 over 2 squared minus 2 times 2. The question is the left side equal to the right side? Let's focus on the left side first. So looking at the left side, 2 times 2 is 4, over 2 minus 2 is 0. We have a problem. 4 over 0 is undefined. Okay, so that's a problem. So since this is undefined, that means that 2 is not a solution. This is undefined. You cannot divide by 0. Okay, so we write the conclusion 2 is extraneous. So if 2 is extraneous, does that automatically mean that 7 over 2 is a solution? The answer is no. We don't know. We must test both of them because there's a possibility that they're both extraneous solutions. So we're going to test x equals 7 over 2. Okay, so we'll plug it into the equation. We have 2 times 7 over 2 divided by 7 over 2 minus 2 minus 11 over 7 over 2. And then on the right side we have 8 over 7 over 2 square minus 2 times 7 over 2. Okay, as you can see, this involves a lot of work. So let's go back to the options and see, do we actually have to solve that equation? Do we have to do the second test? Let's look at the options we have here to see if we can get around that. Okay, so 2 is an extraneous solution. Well, that's a true statement. Bam, there goes the answer. Okay, 7 over 2 is an extraneous solution. If these two are included together, then we have to do the test. Alright, so we already have a true statement, so option 1 is correct. If you look at option 3, it says 0 and 2. 0 is not even a solution, right? So this cannot be an answer. Option 4, this equation does not contain any extraneous solutions. That's false because we have at least one. We don't know about 7 over 2, but from the look of things, 7 over 2 might not be an extraneous solution, but 2 is an extraneous solution. We know that for sure, so our answer is option number 1. Take a look at question 20. It says, given f of 9 is equal to negative 2, which function can be used to generate the sequence negative 8, negative 7.25, negative 6.5, negative 5.75? So from the sequence, we can see that the first term is negative 8. So f of 1 should be equal to negative 8. So which of these options will give us that output? That's the question. So let's test option 1. F of 1 for option 1 is going to be negative 8 plus 0.75 times 1. That's going to be negative 8 plus 0.75, and that is not negative 8. Okay? Number 2, let's test the second option, f of 1. We have negative 8 minus 0.75 times 1 minus 1, which is equal to negative 8 times negative 0.75. 1 minus 1 is 0, which is negative 8. Oh, this works. So does that mean this is the correct one? The answer is no. It has to basically match all these options that we have here. So even though it passes the first test, that doesn't mean that it is the correct answer. All right, let's test another one. Let us test. Let's test the second output. So for f of 2, let's see what we get there. So for f of 2, we have, it should be, f of 2 should be what? F of 2 should be negative 7.25, okay? So if we plug in 2 here, do we get the same answer? Plugging it into this function here, so we have negative 8 minus 0.75 times 2 minus 1. So negative 8 minus 0.75 times 1. If you work this out, you get negative 8.75. And that is a fill right there, so that's wrong. All right, let's move on to option 3. So option 3 we have, let's change the color. Option 3 we have f of 1. Let's try the first one. Let's see what we get. For the first one we have negative 8.75 plus 0.75 times 1. Okay, and then this negative 8.75 plus 0.75. That gives us negative 8. Oh, this works. Okay, so it's either going to be option 3 or option 4. Okay, so let me show you how you can use your calculator to quickly eliminate one of these options. So I'm going to use my table of values to generate the output values for the third one, and if we have a perfect match, then we know that that's the answer. Okay, so we have negative 8.75 plus 0.75x. Okay, if this one is wrong, then our this fourth one should be the correct answer. So negative, have that enter. So here you're just going to go to the table, okay? So look at the output values that we have there, and we're going to compare it with what we have here. So we have, let's go up, negative 8, negative 7.25, negative 6.5, negative 5.75. Well, that's perfectly correct. So we know for a certainty that our answer for number 20 is option number 3, just using our calculators to generate the output values. Thanks so much for taking the time to watch this presentation. Really appreciate it. If you found the contents of this tutorial helpful in your preparation for the Regents exam, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments, just place it in the comments section below, and we'll be more than glad to support you. Don't forget to subscribe to our channel for updates to other tutorials such as this. More clips can be found on math.serve.com. Thanks again for watching, and have a wonderful day. Goodbye.